I'm sure we will see some Valentine's Day problems. I will find on anti-social media tomorrow. All right. -3s from 90 to -30, 12s up to 360, 29s to 870, primes. We're going to just list the primes, and then we'll do a little bit of drawing. All right. No more chattering. No more chattering. Morning, Dean. Good morning, Tiffany. Corey, I see you. I see you. Isn't that like a meme? I see you. ICU also means intensive care unit, does it not? Intensive care unit. Good handwriting, Bradley. Slow down a little bit. Slow down your handwriting, but speed up your math. You need to learn negative numbers because that's how you figure out how much money you owe your parents. Circle your benchmarks, please. Remember, blank paper, way better than unruled paper, way better than lined paper. Less visual clutter.
I'm using blank paper.
Good.
So much.
Very good. Stay in the chat. Copy off me if you don't know what you're doing. Straight down. And we may go over some of the stuff from the handouts on Friday too. So you should have those handouts handy. Good. Should I make some mistakes? Want to find my mistakes? I'll say there's 3 mistakes. Find 3 mistakes. In the chat, nothing out loud. Plot spoilers. Okay, good, Bradley. Good, Joanna. Good, Nyla. Oh, I spelled mistakes wrong. Oh, maybe there's 4 then. Or maybe that's another mistake and then it's 5. I don't know. You can get trapped in some type of infinite loop. Where are you at, Dean? Tell me in the chat. Chrissy, you done? Nobody's faster than John. Hmm. We don't have any Philadelphia fans here, do we?
Me.
Wait, who said me?
Me.
Wait,
Joanna.
I don't know who me is. Me is my least favorite student. Don't ever identify yourself. Who? Joanna?
Corey.
Corey, how are you an Eagles fan? You from Philly? Or you a front runner to they call somebody a bandwagon person. That's what they call a bandwagon person. You know, Mr. Dan, I lived in Philadelphia for 9 years. So I could theoretically root for the Eagles. I wasn't a Tom Brady person. Because I did 20 years in Massachusetts. Maybe 23 years. My in circle's not coming out so well.
Who won last night? I left before the game finished.
The Red Sox. Is that right? The Red Sox?
The Chiefs.
Okay, chat, math. No one else has joke authorization or small talk. Although I know there are a lot of people sleeping. On the East Coast, it's kind of a late game. If I was president, I would make the Super Bowl on Saturday. It's the most counterintelligent thing. Just make it on Saturday. Why are they going to do it on Sunday? Nobody wants to start the week tired. Ridiculous. Ridiculous. Okay. Is anybody done? Tell me in the chat if you're done. I have a question for you. Okay. You tell me, I'll know if you did it correctly. Tell me in the chat. It's easier to do on paper than. And even with all these tools that I have. Getting wildly inaccurate in centers. In circles have in centers, remember? Like you have an inner belly button. Sorry, triangles have, in circles have in centers. And then we have circles that go around. Tell me what shapes they got from connecting the midpoints to the quadrilateral. If you have a ruler, you can be very precise, Tiffany. You can actually measure. I can take my ruler on the screen here. Okay, so no one knows the answer yet. That means you're either getting distracted or you're slow or you failed. Clara Rankin. Get this. We'll get to the primes, don't worry. I don't think you've seen this, Joanna. Write the names out. Some of you still can't spell parallelogram. I have to slow down myself. Pretty sure we're getting a rectangle in the middle. Oh, yeah.
But if you keep on going, you get a diamond and then a rectangle again and then a diamond. And
That's
then
right.
a diamond
You are
again.
100,000,000% right.
And it just keeps on going.
Right. You get stuck in an infinite alternating loop. All right. Clara from the Great White North. The freezing cold North. Where are my mistakes?
You spelled mistakes wrong.
I did. Again? It happened again? Keep going. What else?
Well, I think you do it purposely.
No, I didn't. Christine wrote it out. Go ahead.
No, you wrote that out.
No, Christine has access. She's a terrible speller. Speller, not smeller. Terrible speller. Where are my mistakes in here?
I think you're missing 57.
Think I'm missing 57? I don't think so. 57 is 3 times 19.
Oh. Okay, I'm not sure. I was
Well,
working.
Bradley gave me a mistake. Bradley, unmute yourself. Tell me the mistake.
So I wasn't really finding your mistakes.
All right.
87 is not prime.
87 is in our threes. Good. What should 87 be? Be 89. Be 89. What else? 2 more mistakes. Good, Clara. Clara from we got the Great White North, and then we have the South, Deep South.
And 87 is in the 29s.
Not 19s. Well, yes, it's 87 is in the 29s, right? 87, good division. 3 times 29. Okay. So what's the other mistakes? Who said it? $119. What about 119? Nyla, mute yourself. What's wrong with 119? Factor it.
In our sevens?
How many sevens? No asking. You give me the whole thing. How many sevens? Come on, faster. 7 times 17. You got to do this long division in your head. All right, what else? So we had this one. I feel like there's another one. What about 51? 51 is not prime. That's 3 times 17. Okay, we need to know 51 because 51 and 91 are the 2 biggest, what would you call them? These are the 2 biggest traps with primes. 53 is prime. So 53 is prime, 59, 60, 2 in the 60s, 3 in the 70s, 2 in the 103. These are the beginning 4 that John always points out. 113 is prime, 119 is not. 1 in the 120s, 3 in the 130s, and 149. All right. Let me save this and put it into our. If you have any questions, you ask me in the chat. Warm-ups. What's today's date? The 13th? Is that bad luck? Tuesday the 13th? Valentine's Day Eve? Good thing you reminded me. Good thing you girls reminded me. Make sure I leave. I'll put $20 in an envelope for Mrs. Lazonis tomorrow. All right. So remember, we're connecting angle bisectors. The angle bisectors, write this word down. They are concurrent. Write it down. That means they always go through the same point. You draw two of them, they intersect. The third one should always go through that. If the third one's not going through it, at least one of your angle bisectors is wrong. Okay. Write down the word concurrent, write down the word in center. Okay. And then also we have a, is it called in radius? I can't remember. Might be. Okay. But the radius of this circle is sometimes, I think it's called in radius. All right. Does anybody remember why this happens? Clara from the Great White North, do you remember why we get a parallelogram? Okay. So if you draw another one, if you draw any quadrilateral and connect the midpoints, you are going to get a parallelogram. That's because this line here is parallel to this line here. They are both half of this diagonal. Those two purple lines will always be parallel to the diagonal and also half of it. Okay. And the same thing works on the other side. Something nobody knows but you kids in this class. Okay. All right, we're always going to get a parallelogram. Doesn't matter what. And you should doodle this until it's burned into your brain. It's actually kind of fun to do. What do you think I did when I was in school and bored out of my tree? I doodled in circles and telescoping midpoint. There's a word for this. What is the word for this? I forget what it's called. Let me search for it. Connect midpoints of a quadrilateral. There's a word for it. Resulting is always a parallelogram. We know that. Thank you, geometry help. I think it's called something. Name of parallelogram. I don't know. Come back to it. All right. Where were we? Caleb is not here. Caleb is not here, but he sent in an area maze. Caleb's in Taiwan, or he's on his way to Taiwan. So let's look at his area maze and see if we can solve it. Okay. Now you need to draw it yourselves. Okay. I do too. Looks like he used a crayon here. But it looks like what he did was why is that not working? In rectangle. Oh, I know. It looks like he used the one we did in class the other day. Okay. So draw a rectangle here. Cut it into I don't know, 6 pieces. 6 unequal pieces. And these are unequal, 17 and 11. Doesn't have to be exact. Don't go crazy. Just make sure that this is bigger than that. And then he's got it jutting out here. Chicken wing. Like a chicken wing from our Ken puzzle. Okay. I'm going to use 2 different colors. I'm going to use green for the area, 72 inches squared. 17 inches squared. Somebody should remember that his little, because he's the one who solved that puzzle in class the other day. 96 square inches. You might have a mistake in here. I didn't check it out yet. 31. 11. I'm not going to write inches squared because it's too tedious. Okay. And then I'm going to use orange for length. Okay. Who wants to start? Who wants to solve this one? You can do it out loud.
I will.
I don't know who I is.
Winston.
Is I related to me? All right.
No.
I is not related to me? I think it is.
It's related to Winston.
Oh, this is self-referential. All right, give me 1 second. All right, good, Winston. I'm ready for you. Where am I going to start? Where am I going to go?
It says that there's a 9.
Yeah, that's a 9 here.
72's length is 9, so its height must be 8.
Okay,
And
good.
that means 8 and 96. The 96 also is 8 high, and that means it must be 12 long. And 12 long would mean that 31 and 108 would be weird things, but 108 would be 9 times 12.
Wait, you think 31 over 12 equals weird? Give me a mathematical term for it. Weird is not a mathematical term. You mean it's a mixed number?
Yeah.
Mixed hashtag? Okay. So it's not weird, right? Remember, when you're on TV one day and you're super famous, Winston, you have to be able to articulate yourself accurately. Okay? So it's not weird, and we're not allowed to use mixed hashtags, right? Let me write out mixed hashtags. Okay, good. So you're 12 up here, then what?
That means the height of 108 box has to be 9.
Okay, good. So that's 9.
What, and we can figure out the. Please stop. I know. I don't care. I'm in my class. That means that stop, please. The width of
Question mark.
the question mark is 6.
6. So you think
Since the height was 9, the answer must be.
Okay, so we can just be clear. How do we get to 6 here? You did 27 minus
9 minus 12.
Yeah, minus the 21. 6. Okay, so 6, 9, and then the area of the question mark is what? 54 inches squared. Okay, good. Okay, good job to you, and good job to Caleb. All right, so I'll have to put this in the book. Okay, so Caleb will get. Did I have a picture of Caleb for the book? Let me just see if I had a picture of Caleb. So we had the puzzle book. Where's the puzzle book? Templates, puzzles. Let's see if I had a picture of Caleb. I don't know if I did or not. I don't know if I had a picture of Caleb yet. Did he give me a picture of himself? Now I look at it's a good picture. I don't know. All right, we'll have
And
to.
my picture isn't on there
Your picture should be there. Let me see.
because I sent in it.
Yeah, you did, and I remember I cropped it. Let me see.
Did I send?
Let me see. Puzzle book, kid pictures. Yeah, you're here. So let's see. I'll pull you in. I'll pull you in the thing now, so I don't have to look for you again. I don't have to look for you again. I go crazy trying to look for. Whoa, you're bigger than everybody else. Wow, that's not fair. All right, so I'm going to put Caleb in here in the rough thing, so I don't forget. Okay, his is going in here. And we have to redraw that maybe. No, don't resize it. We crop it. All right, so pull out the. Oh, wait, I have one good question. One little question, I think, and so this is Caleb. I'll just write it in here so we don't forget. It's saved under his name. Stop it. Computer's acting wacky. And the internet was down on Friday. And it generally gets really slow here during this tourist season. All right. Oh, I have 2 questions. All right. What's going on here? I know Winston's going to like this question. This is, okay. So this is like a physics question. Okay. Nobody answer yet. We have to go slowly here.
Why is there a question mark? What are we supposed to answer?
Yeah, okay, let me explain it. Okay. So these are gears, right? So these gears here, he's gonna turn. He didn't even do a good job making an arrow. He made like a half arrow. But basically he's gonna turn this one. What do the Brits say? Anti-clockwise, counterclockwise. And when this wheel turns this way, these teeth grab it and it does something to this gear, which 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 does, oh boy, I gotta have to send this question to John. I don't trust myself on this. And so now this is this kid in India who's making these puzzles. He wants to know what it does to this final gear. Is it gonna go clockwise? Well, that's counterclockwise. So actually, I think I've seen people do this. This is counterclockwise and this is clockwise. So how's it going to spin this one here? Now I'm just going to get you started on this. Maybe I'll put it on a worksheet so you can look at it at home. It's going to provoke a lot of arguments. It's going to provoke a lot of arguments. Oh boy, I want to erase this up here. Okay, so counterclockwise or clockwise. Let's just see. When the teeth go this way, let's just try to agree on one thing. When the teeth go this way, Winston, what is it going to do to this one here? Is it going to go clockwise?
It's going to go clockwise.
Okay, so so if I put a CW in here, that's clockwise.
Mhm.
Okay, so as this spin, wait a second. This goes this way, so now this is going to spin this way. Is that right, Winston? And then what's it going to do to this one here? Oh, maybe it's not so hard.
Then it's going to make it go clockwise. I mean, it's going to make it go counterclockwise.
It goes CCW.
Mhm.
And then this one has to be clockwise. So if this is going clockwise, that means this is going
Counterclockwise.
wait a minute. This is on its side. This is spinning this way, so it's pulling these down. This is CCW. Well, what are these things doing in here? Is this going to reverse it or something like that?
That's going to make it go counterclockwise. I looked at it. And
You think this is going to go CCW also?
yes.
Right, now that's where I would go dizzy. All right, so you may be right. I'm getting dizzy. I'm going to put this.
No, it's going to go clockwise.
This is where I mean, I need help from some of you smarter kids because I'm too old to figure this stuff out. This thing goes this way, so that's going down. It's pulling it down. I feel like if this
The top part of the band, and it's pulling, and it's attached to the bottom part of the gear. It's pulling that up. Well, it turns counterclockwise, and that means also it's turning that way too. So it has.
I know you. All right, I know you kids love these. Let me clear this out so I can get a clear image for when I send it. I'll just put it on a worksheet and you all can work it out yourself. Okay. I don't think I saved this yet. I don't want to lose it. All right. And I have other things we'll move on from. I like to leave these open loops for you all. Let's see. 20. I think we did that one. 20, okay, 29. All right. This is $1 million here. What are its dimensions? What are its dimensions? Okay, so I don't know if you can see this. I couldn't see this either. These are 100. Each stack is 100. Okay, so I want everyone. Let's see if you can figure this out, Dean. Wait a second. This is too messy. This is too messy. No, it stinks. Say the word stinks. Don't say that other word. Let's see. $1 million. Coolest website ever. Allows me to crop out people. Let's see if I can download it. Okay, download this. Okay, that's fine. This is going to give us more room. All right. So $1 million. So you're all math, Winston, all math is
factoring?
All math is factoring. Now it's too small. This is too small now. We have to go back to that one. I'll just save that for later. Okay, all math is factoring. So how do you factor a million? We want to figure out the dimensions of this.
2 times 5 times
Well, just
2.
give me, let's, you don't need to go all the way prime on it. You don't need to do a prime factorization. If you had a cube that was is it a cube? Is a million a cube?
It's
What is What is There's nothing about math. How many zeros in a million, Winston?
there's 6.
Okay. How about 100 cubed?
Oh, it's yeah, that's what I was gonna say.
So if you had a cube, and you went 100, this was 100, this was 100, and we had 100 this way. It's not a really good cube, but whatever, my picture's in the way. That is a really bad cube. Bad example for you kids. Okay, it would be 100 by 100 by 100. So we're going to try to figure out the dimensions of this here. Now, Dean, unmute yourself. We're going to try to find the dimensions. Ready? Dean, you awake?
Yep.
All right. So, Dean, if each packet, I don't know if you can see this, hopefully you have a big enough screen. If each packet is 100 ones, they're singles.
That's supposed to be a million.
It's $1 million. It is.
Okay.
Okay. So this is 100. 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 Can you count how many 100? What we have on the bottom?
What do you mean? Like how many rows?
Yeah, you can count the blue lines.
7.
7, right?
Yeah.
So our bottom is, this is $700 on the bottom. Each brick is
$100.
is $100. So this is $700. Okay. Now counting this way is a little bit tougher.
Yeah.
So it's 1, 2, I'll have to do it. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's 14. I think it's $1,400.
That makes sense to be 14.
1,400. All right. So 700. Well, you could say we have 700 across the bottom, and then not 1,400. Excuse me. This is 14 times 700. Right? 14 packages of 700. Now, how many columns? Let's just try this out, because they said it's 100. They said it's $1 million, but they could be lying. Maybe it's not $1 million. So we're gonna fact check, and if they're wrong, I'm gonna go on Twitter and tell them that's only $460,000 or whatever it is. So now we got to count, and I'm gonna have to enlarge this. We're gonna count packets up. Whoa, it's gonna be hard to count. I should make Chrissy count this. Now they're uneven, right? They're a little uneven, but we'll get a rough idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. All right, so 52. Wow. Let's see if we can figure this out. So we're getting 52 stacks. 52 stack approximately. So 52. It's really what we have is 52 times 14 times 700. Somebody type that into a calculator. excuse me, times 700. Right? Is that right? We have no. Hold on a second. Let's be clear. We have $100.
I counted 50.
Yeah, this is right. Okay, yeah, that's who knows? I think it's higher here and there. We're just going to get approximate. So it's not times 700. It's 52 times 14 times 7 times 100, right? So it is times 700, but these are the dimensions. These are the stacks, right? These are the stacks. Christine, somebody multiply that out. Tell me in the chat. Aha. Is that what you got, Nyla? 500,000?
Yep.
So, okay. So that's not even close to $1 million. So what, Nyla, what did you write? 509,600. Yeah, Chris, 509,000. 509,600. Now it's probably a little more because I counted a lower stack. It could be higher here, but this is a lie. So do you think I should go on Twitter? Now Winston, what change could you make to make this $1 million? What change? Let's see how smart Winston is. Make one change to make this $1 million.
Wait, so that's not actually $1 million?
Yeah, it's not.
So why
In
would
the
they
chat,
do that?
make one change to make $1 million. Well, let's see if anybody knows it. Hi, Corey. Make one change. Now, and then I'll tell you where else I do this. We're fact checked. Make one change to increase to 1 to 10 to the 6. Who's got the change? No, that wouldn't work. Nyla, that's actually the wrong. Think about it. You're in the right track, but you gave me the wrong number. Okay, 2 crates would work. 2 crates equals 10 to the 6 buckaroos. What else? What else? How about if we did $2 bills? Has anybody ever touched a $2 bill? Wouldn't that double everything, Dean?
I have 2 of them.
You have 2 of them. Yeah, and I've been to conferences where people hand out $2 bills as like, as like gimmicks. Actually, one of them was like, you give me $1 and I'll give you $2 back. Like it was a double your money type of marketing thing. All right. So I also do this on puzzles. Okay. I do this on puzzles because you will see something say, puzzles are liars too. So I want you to do this at home too. So you do puzzles lie also. Okay. So what happens is you have a puzzle. And it says 1,000 pieces. Now, why? How do I prove? Or how do I catch them lying with a puzzle? Winston, here's your hint. I mean, most of the puzzles are like this. They're very rectangular. They're like 32 by, it might be 32 on the bottom, or it might be like 41 across. This 41 times whatever integer this is not going to be 1,000. Okay. 1,000 is not a perfect square. Well, not a perfect square. It's not divisible. Excuse me. That's the wrong way to look at it. It's not divisible by 41. So if I count 41, if I counted 50 across the bottom and 20 up, yeah, that's probably 1,000. But it's never like this. It's like weird numbers. Okay. So that's how I catch them lying there too. All right. I have an unscramble, but we'll save it for tomorrow. Let's see. I wanted to finish up. Well, the 2 Kakuros from last weekend, maybe we'll get to maybe we'll get to, was this one? Which one were we doing? 26, easy one. Okay, this one should be almost done. It says easy. I'm gonna go fast. It's late in the class. I'm gonna speed up. We got these numbers here, 2 and 4. This has to be 1 and 3. Uno y tres, 1 and 3. This has to be 1 and 3, our unique sum that adds up to 4, right? Right here. All right, what do we know? We have 4 here. So we need 8 to get to 12. Now, how do we make 8? 7 and 1, 6 and 2, 5 and 3. Now, we could do 6 and 2. That's possible. We could never do 7 and 1 because we would not be able to, we would squeeze out the 9. So 7 and 1 is out. Okay, remember, we're trying to get to 8 to complete this 12 here going down. Okay, so could we do 6 and 2? Let's just try it out. 2, 6. Now this 3 has to be 1 and 2. This would have to be 1 and 3. Yes, that works. This 6 and 2 is a possibility. Okay. Let's try 5 and 3. 5 and 3. We could never put the 5 here, right? Because what are we going to put? Fractions in here? We would have to do no, we can't do 5 and 3 because the 3 would clash with one of these. Okay. Ergo, therefore, we are doing 6 and 2 in here. And we know our 6 is going to be here. 6, 2. Now we need a 1 and 2 in here. Look, 1 and 2, 1 and 2. We can't put a 2 in there. 1, 2, 1, 3. Okay, we're good, but we're kind of stymied in this. This could go either way here, right? We're going to have alternating 1s and 3s. It's going to go 1, 3, 1, 3, 1, something like that, or the other way around. Okay, so we have to work our way up this way to complete this, or we can also come down this way and get clarity on this 1 and 3. Okay, so 1 and 3. 1 and 3, this is also 1 and 3 here. 1 and 3. Okay, 16 is 7 and 9, a unique sum, 7 and 9. 8 and 9 for 17, 8 and 9, 8 and 9. Well, this is going to be 7, 8, and 9 going down, right? 7, 8, and 9. But we have a problem. 29. What does 29 have? No, 29 has 5, 7, 8, and 9, right? So 5, 7, 8, and 9. 5, 7, 8, and 9. Christine, what do we know about this and this? Unmute yourself.
8 and 9.
No, well, this is 8 and 9. What about this one?
It's 7 and 9.
7 and 9. Okay, so only 7 and 9. Whoa,
So then
7 and
go
9 and
right
8
up.
and 9. So what about
Go
the
up.
5?
Yeah, that has to be a 5, but you should know what's in the box right above that too.
Above the 5. All right, let's put the 5 in and then we'll look there. So this has to be our 5. We only have one spot for the 5 going here. We only have one spot above it. You think we should know what goes there above it? Really?
You should know it goes in all 3 of those boxes.
Okay, so all 3 of those. 23 is a unique sum too, right? What equals 23? Well, 7, 8, 9 is 24. 23 is 6, 8, and 9. So we have another unique sum here. So it's 6, 8, and 9. 6, 8, and 9. You could never put a 6 and a 16. You could never put an 8 here because it would double it up to make 16. So this has to be the 9. That means this has to be the 8. Okay, let me put those in Einstein blueprint blue. 9, 8, 9, 7, 8, 6. White out. White out. Okay, this 8 here forces a 9 in there. Okay, this is going to be done. This is the easy one. We'll get to the hard one. This is going to be a 9. This is going to be a 7. This is going to be a 9. You should have finished this at home, by the way. 9, Christine finished it quickly. This has to be a 1 or a 3. Well, we have 11 and 17 is 28. This has to be 1 to get to 29. Add them up quickly. This has to be a 3, 1, alternating. 3, 1, 3, 1, 3, right? With 4 is 1 and 3. We need 1 and 2 in here. We cannot put it this way. It has to go 2 and 1. 3 and 1 makes 4. What do we have? We have 6 here. We need 10 in here. We need 9 across. What makes 10? Well, this has to be 1 and 3. Christine, you want to guide us through the last part? This has to be 1 and 3, 1 and 3. We need 10 in here. How do we make 10, Chris?
9, 1, 8, 2, 7, 3, 6, and 4.
Okay, so we can't put a 9 and 1 in here because there's a 1 used up, right? Can't do an 8 and 2 because the 2s would clash. Can't do a 7 and 3, same thing. The 3's used up. This has to be 6 and 4. Okay, and I will go blue. Right? The 6 has to be here because otherwise the 4s would clash. So that's a 4. Now we have 10. Christy, what goes here?
A 1, 2, 1, 2.
2, then 2 and 1 and 1 and 3. 1, 3, and 4 makes 8. 2, 1, and 6. All right, we're done that one. We went to sound effects. Where are the sound effects? Caleb really wants the sound effects. He's having a problem. Didn't we have applause? Anyone? Awkward cricket sound. Didn't we have clapping? What happened to our clapping? Didn't we have clapping? Oh, I remember that one. All right, next one, and then we're done. We'll take a hack at it. We'll take a hack at the hard one. I don't even think, Chrissy, did you finish the hard one? This is the right one. Yeah, this is it. The expert level. Okay, so it was on the printout from the other day. We're gonna get started here because I don't think we can finish an expert one in the time allotted. Always write them out on your sheet. I don't think they're on the handout. We need to stare at these numbers. All right, 30 is a unique sum. Okay, 30 is a unique sum. We're gonna have to write some small numbers in here. 6, 7, 8, 9. 6, 7, 8, 9. That means this is 1, 2, 3, 4 here. 1, 2, 3, 4 to make a 10. 6, 7, 8, 9. Clara, count the boxes across from here and get back to me. 1 and 2.
8.
1 and 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. We're missing what number? We're missing a 5, right? Remember they add up to 45. A rank and sum. So there's no 5 in here. That going to help us out? We'll just put that there for future reference. 1 and 3. Nyla, why can't I have a 1 here? Look right. Why can't I have a 1 there?
It's too small to go to 27.
Yeah, the most these 3 boxes can be.
Uh,
24. All right. So that has to be the 3. And now these are going to be 7, 8, 9. Okay. You can't put a 9 in here. And you can't put a 6 in here because it's 7, 8, 9 across. Nyla, can I put a 9 here? Look up.
that's too big for 14.
Yeah, we can't get a 5 with 3 numbers. Our minimum is 6. Okay. So 9 can't go here. 9 cannot go here or here. That forces it into there. Okay, that should help us.
Mr. Dan, also we need the one above the 3.
Also, we need what? A
One above the 3
Okay.
to create 4.
So the 9's gone here. Also, the 1 is gone in here. I'll put that in here. Thank you, Clara. Okay, let's see. What else can we do? Now we need 7 and 8 in here. We can't put an 8 because that 1 would double up as we get to 9. So we got a 7, deuce, 8. Now we need 6 in here. 1, 2, 3 is 6. There's no 4 in 6. So I'm going to get rid of the 4. If there's no 4 here, there's no 6 here. There's no 4 there. There's no 6 there. All right, 18. Christine, can we put a 1 here? I guess we can, right? 17. Yeah, we can put a 1
We
there.
need a
8.
1. We need 1, 2, 3, right? In the 14.
In the 14, we need 1, 2, 3. Correct.
Yeah. Well, the 1 and the 2 are already used up, so that's a
Excellent eye.
that's a 3.
Excellent. So this is the 3. This is the 2. This is the 8. Okay. Good. And then this has to be the 1. And then we need 7 and 9 in here. That's going to have to be 7, and that's going to be a 9. There's never going to be a 6 or an 8 in there. Okay. Well, expert schmexpert. We're making progress here. So then this here has to be the 6. This has to be the 6. Now there's no 5 in here. So we're missing 4, 6. So in here we're at 4. No, we have a 6. We're missing 4, no 5, 4, 7, 8, 9. 4, 7, 8, 9. Now we can't put an 8 here because that would be a 0. We can't put a 9 here because that would be a -1. So no 8, no 9. We can't put a 4 here because that would double up. So it has to be a 7 as far as I can tell. 7, 1, 7. We need 5 in here. How do we make 5? 4 and 1. Only way we can do it. 2 and 3 would not work. It has to be a 1. We need 14 here. That's 6 and 8 or 9 and 5. Again, we need 8 and 9 in here. 8 and 9 in here. I'm going to put them in small purple. We'll find one more thing and then we'll stop for the day. Give me 1 second. Okay. Let's see. We've got, do we have any unique sums up here? Okay. Well, we got 3, 1 and 2, 1 and 2. 8, we know it's going to have a 1 in it. Doesn't help us. 10, there are a few different ways. 19, got some restrictions. Nothing. 2 different ways for that. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. We're using all the numbers except for the 2. Okay, we're using all the numbers except for the 2. Okay, so therefore, this has to be a 1. All right. Dallas, if your mom's there, maybe you can stay for a minute afterwards. All right. All right, good job, everyone. We will see you. Let me stop the recording. I was recording that, right? Yeah.